This is Sewer3D, photogrammetry, 3D modeling, and cloud computing in sewer condition assessment. My name is Eric Sullivan, and I'm with SewerAI. What is Sewer3D? Sewer3D is software that takes 360 videos, such as what's captured by the very affordable GoPro Max or any of the other 360 action cameras out there, and upon ingesting a video of a manhole inspection into the SewerAI cloud platform called Pioneer, our process automatically renders a detailed textured 3D model of the manhole, which enables a user to measure and analyze the geometry of the sewer structure. In this case, manholes and other vertical access points. The method used to render these 3D models is called photogrammetry. Photogrammetry is the use of advanced mathematics to calculate the position of digital pixels as points in 3D space. Inside the 3D model, one can quickly measure components in the structure, conduct custom point-to-point measurements to an accuracy of 1 centimeter. There's also a 2D unfolded view of the structure, which can also enable vertical measurements and can be useful for identifying connecting pipes or missing bricks, etc. Also, there's a 360 video with interactive virtual pan and tilt as if you're standing inside of the structure looking all around. No software is required to use these technologies in the cloud other than Google Chrome or Microsoft Edge browsers. The Pioneer platform also enables the user to conduct NASCO MACP Level 2 surveys, export them, and can also be displayed within Esri ArcGIS online map layers. So why does this matter? First of all, this can be done with easy to acquire and use consumer level action cameras as opposed to some of the legacy systems involving specialized scanning cameras, making the entire process substantially easier. The 3D models can be used for a variety of purposes, as previously described. One of the most impactful aspects of Sewer3D is that it drastically reduces the CapEx upfront costs for contractors or sewer utilities to outfit inspection crews. Because photogrammetry is an alternative method to LiDAR, which requires the use of thousands of laser points, the cost of the equipment systems, again using consumer available action cameras, is reduced by anywhere from 83% to 92% when compared to legacy equipment for manhole inspection. In terms of the per manhole or per inspection cost, which includes crew labor and fuel, we've seen that a contractor or sewer utility can achieve anywhere from a 28% to a 53% cost reduction per inspected manhole. Also, the process to capture the data is very efficient, requiring less than 10 minutes per structure on site to conduct the inspection in the field, and anywhere from 15 to 45 minutes of compute time in Pioneer to render the 3D models in parallel. Let's quickly get into one case study that demonstrates how this technology is being used on the ground in real life. One of the biggest wastewater collection systems in North America is the city of Houston. They have 129,000 manholes that they're responsible for. They're currently in the beginning of year 3 of a fairly onerous consent decree requiring them to inspect their entire sewer system. And prior to the engagement that we began with the city, which was in September 21, they evaluated AI and software vendors from all around the world. We've since become the platform of record for the city of Houston and the consent decree stakeholders when it comes to sewer inspection data management. The data is being collected by a number of different contractors and is uploaded to Pioneer, and the different stakeholders involved all have near real-time access to all this data and project updates in terms of what's been inspected and what remains, but also, importantly, they can get the condition rating outputs from the NASCO assessment process, which gives them what they need to conduct capital planning, rehab, and implementing repairs and new construction work. Currently, the scope is around 10,000 manholes a year of MACP surveys being completed by SewerAI. Also, a third-party study was conducted to look at the accuracy of the AI-assisted assessment process, and it found that SewerAI outputs to be around 8 times more accurate than what the contractors had historically been providing the city. And in terms of the precision of the annotations, it was found to be 97% accurate in this study. In summary, reviewing the various use cases for Sewer3D, you have, of course, new construction, verifying the as-builts with what's been installed in the ground. We've already discussed the ability to conduct NASCO MACP Level 2 assessments and determine structural and O&M index ratings, as well as metrics around likelihood of failure. Also, for lining companies or other construction activities, you have verification of diameter of pipes and depths of pipes in the sewer system. Also, from a GIS accuracy standpoint, that can be valuable. From a rehab planning standpoint, you can now calculate exactly how much material might be needed to repair that specific structure. For future use cases coming shortly, we would be talking about the enablement of digital twins for high-level flow or hydraulic modeling and deterioration scenario planning. And also you have the enablement now of 3D printing or additive manufacturing construction methods, which now finally can start to be used inside the sewer space. And then also the technology will allow for not just the 3D modeling of vertical access structures, but also for 3D modeling of horizontal pipelines. Thank you all so much for taking the time to watch this video.